Hey there, awesome physics students. Let's talk about the force a wire carrying current will feel while it is in a magnetic field. So here we have a magnetic field that points into the screen. Here, that's our magnetic field B, and a current carrying wire with the current labeled in the direction of the arrows. And as you remember about current, we treat the direction of the current as the direction positive charges would flow if positive charges were flowing in the wire. So let's imagine that we have positive charges flowing in the wire in the direction of the current. So the velocity of those positive charges will be down in this segment of this vertical segment of the wire. So if we apply the Lorentz force law to this situation, V points down, Q is positive, so QV points down as well. If you take your right hand and push QV into B, you get a force to the right here. And so the Lorentz force would predict a force in that direction to the right. Now, of course, we know that it's actually electrons, which are negative, moving in the wire, and they're moving in the opposite direction that the current flows. And so let's see if that makes a difference. Let's imagine we have a negative charge and it's moving opposite direction the current, and so it has a velocity up. So V is up, but Q is negative, so QV actually points down. And again, we push that into B, which is into the screen, and the force again is to the right. And so this direction is correct. If you do the derivation and the application of the Lorentz force law on this situation, the force law for a wire is just the length of the wire. So that would be the length of this vertical segment here. I'm going to draw that as L, just that vertical segment, times I as a vector. That's a vector that has the magnitude of the current in amps and points along the direction the current is flowing in the wire, cross B, the magnetic field. Okay? And if you look at the units carefully, you'll see that this gives the correct units for force, and this really just comes from the Lorentz force law, QV cross B. Finally, let's note that the force is going to be perpendicular to both the wire and the magnetic field. And it's going to, because it's a cross product, just like the Lorentz force law, that force is going to be maximum when the current and the magnetic field are perpendicular to each other. If they're at an angle or a little bit parallel, that force is going to be less than its maximum value. All right?